Welcome to lesson 3-6. Today we're going to be talking about equivalent expressions. Expressions are equivalent if they give you the same answer. So we have that word equal kind of built into equivalent, and then we have expressions, you know what they are. So an example might be, 2x is equivalent to x plus x. So for instance, if I were to choose a value of x equals 2, then I would get 2 times 2 equals 2 plus 2. And of course, 4 equals 4. If I were to choose x equals 12, I get 2 times 12 equals 12 plus 12. That's also true. So no matter what I choose for x, they're still going to be equal, making them equivalent expressions. To help us prove that expressions are equivalent, we're going to use some properties. One being the commutative property. And the word commutative has the word commute in it, which means to go from place to place. Like maybe perhaps your parents commute to work and then back to home. So the commutative property, there's one for addition and multiplication. The commutative property of addition says that the order that we add does not matter. So 3 plus 1 equals 1 plus 3. Or a number plus a different number, we can swap them around. Doesn't matter what they are. Multiplication, same thing. I could do 4 times 2 gives you the same answer as 2 times 4. Or n times m equals m times n. Order does not matter when I multiply or when I add, according to the commutative property. The associative property is very closely related to the commutative property, and it has to do with the fact that with addition and multiplication, it does not matter the order in which we do those operations. So associative is just based on groupings instead of just switching the order. So if you associate with people, you're in that group. So let's look at what that might look like for addition. If I have A plus B plus C, I can group these differently and get the same answer. For instance, I have A plus B plus C. Notice the ABC stayed in the same order. I just grouped them differently. And that's important because once we start moving those variables around, now we're getting into commutative property where we're actually switching the order. In this case, the order is the same, but we're grouping them different. Let's give an example here. 1 plus 2 plus 3, does that equal to 1 plus 2 plus 3? You can add in any order, and yes, indeed, that's 6. I get the same answer. So there's an associative property of addition that says how we group our add-ins does not matter. We also have an associative property of multiplication, which says that if I have A times the quantity B times C, I can regroup this. The order in which I group these things does not matter if everything is multiplying. Here's an example. If I have 1 times 2 times 3, and I multiply the 2 times 3 first, I get 6. If I do it by grouping the 1 and 2 first, I get 6. Same answer. So by the associative properties of addition and multiplication, I can group the numbers any way I want to. The last property we're going to deal with is the distributive property. So if I have A times B plus C, that's equal to A times B plus A times C. In other words, I distribute the A over the course of the two numbers. Let's look at an example of that. If I have, for instance, 3 times 4 plus 2, that's equal to 3 times 4 plus 3 times 2. 3 is distributed across the 4 and the 2. Let's look at that as a picture and see why that works. 3 groups of 4 plus 2 is right here. Here's one group, 2 groups, 3 groups. I have 3 groups of 4 plus 2. That's the same as 3 groups of 4 plus, that's that right there, and I have 3 groups of 2. So you can see it in kind of in more of a graphic form there. Okay, so in this one, they want us to write an equivalent expression to 3 times 4x minus 1. And they want us first to use the distributive property, and then we're going to use the associative property. So let's start with the distributive property. If I use the distributive property, this is going to be 3 times 4x minus 3 times 1. I've distributed that 3 across the 4x and the 1. Now I'm going to use the associative property to regroup this. So this becomes 3 times 4 times x. See, I regrouped. Minus, and then I have 3 times 1. And now I've got 12x minus 3. So 3 times 4x minus 1 is equivalent to 12x minus 3. Okay, so we used the distributive property and we used the associative property. Okay, on this next one we want to use the distributive property again to write an expression equivalent to 2x plus 4. Well, I don't have parentheses there, so what do? Well, we're going to reverse it. I want to use the distributive property to get something times something plus something. So I need to look for a factor that's in each of these terms here. And I see an even number in both of them, so I can pull out a 2. So if I pull out a 2, then I think to myself, well, what times 2 is 2 times x? Well, that's just an x. See, 2 times x is 2x. And what times 2 is 4? Well, 2 times 2 is 4. See, 2 times 2 gives me my 4. So there's my 2 parts. So I used the distributive property in reverse. Okay, this is one for you to try. We have the expression 3y minus 9, and they want you to use the distributive property to come up with an expression that is equivalent to it. So it looks like we're reversing it here also. So you're going to come up with something times something minus something. Notice I said minus, and that is because that operation is subtraction between those two numbers. So find a factor that's in 3 and also in 9, and you're going to pull that common factor out. Alright, so here we're looking for equivalent expressions. So 2 of those are equivalent, 1 is not. And so I see parentheses here. So right away I'm thinking distributive property. So if I had 4 times 2x minus 1, if I used the distributive property, 4 times 2x is 4 times 2 times x minus 4 times 1. I get 4 times 2 is 8 times x minus 4 times 1 is 4. I get 8x minus 4, which happens to be exactly this. There's no way to get to 4x from these using any properties that exist. So equivalent are 8x minus 4 and 4 times 2x minus 1, and not equivalent is 4x. Alright, here's 3 more expressions, and we want to see which ones are equivalent. Use the properties that you know. Use the commutative properties, where it doesn't matter the order that you add or multiply. You could use the associative properties, where you group differently when you add, or you group differently when you multiply. Or you can use the distributive property. See which properties help you here. Okay, now here's actually an easier way to see if expressions are equivalent. We can substitute in a number and see if they're equal. So here we go. If we have 6 times the quantity n plus 3 minus 4 and 6n plus 14, if they are equivalent, then they're going to be equal for anything you put in for n. So pick something relatively easy. How about 10? If I put in 10, that's going to be 6 times 10 plus 3. I'm going to make n equal 10 minus 4. And I'm going to get 6 times 13 minus 4, and that's going to be 60 plus 18 is 78 minus 4 is 74. If I come here, it's 6 times 10 plus 14. That's 60 plus 14. I get 74, and they're the same. Okay, last thing here, you have one to try out. Use substitution to tell me if 2 times the quantity x minus 3 plus 1 is equivalent to 2x plus 6. Pick a value for x Give it a try. See if they're equal. All right, how about some straight up practice here? True or false? These expressions are equivalent. Well, look at this one here. You could use hint, hint, the distributive property, or you could substitute in a value for r and just see if they're equivalent. Same thing with the one below. You could use the distributive property, or you could substitute in a value for t and see if they're equal. Try them on your own. We'll talk about them in class.